The power of air. Fundamentals of flight. Air pressure and lift. Narration. The compressor stage of a jet engine significantly increases the air pressure by forcing air through a series of rotating blades, which is necessary for efficient combustion in the engine. The streamlined body and aerodynamics plays important role in creating thrust and lifting a jet efficiently. Combustion of air and fuel mixture boosts engine to reach its destination. Here air pressure plays important role. The body of an airplane and jet is designed in such a way that the jet can fly in air. The plane has two wings and tail, head and combustion chamber. The primary lift force on an aircraft comes from the wings, which utilize the principle of pressure difference created by airflow over their curved surfaces. The jet engine's operation relies on compressing air to high pressure within the engine, which then expands rapidly through the nozzle to produce thrust, propelling the aircraft forward and contributing indirectly to lift by allowing the plane to achieve sufficient speed for its wings to generate lift. Air-breathing jet engines typically feature a rotating air compressor powered by a turbine with the leftover power providing thrust through the propelling nozzle. This process is known as the Brayton thermodynamic cycle. The engine core. The heart of thrust. The principle of combustion and turbine function. The combustion chamber in the jet engine undergoes four processes: intake of an air through intake valve. The fuel and compressed air mixture is burned in the cylinder, creating high thrust to lift a jet upwards. The principle of combustion and turbine function is based on the rapid release of heat energy through burning fuel, combustion, which creates high-pressure hot gases that expand through the turbine blades, causing them to rotate and generate mechanical energy. Essentially, the combustion process creates a force that drives the turbine to spin, converting chemical energy into usable mechanical power. Combustion. Fuel is mixed with air and ignited, causing a rapid chemical reaction that produces hot gases at high pressure. This process happens in a combustion chamber within the turbine system. Turbine function. The hot gases from combustion are directed through the turbine blades, which are designed to efficiently capture the expanding gas energy. As the gas expands against the blades, it pushes them to rotate, generating mechanical power. The science of propulsion, understanding jet engine power. The relationship between fuel and thrust. The relationship between fuel and thrust is that more fuel burned results in greater thrust. However, this is measured and compared using a metric called thrust-specific fuel consumption, TSFC, which indicates how much fuel is needed to produce a unit of thrust, essentially showing the fuel efficiency of an engine. The lower the TSFC, the more efficient the engine is at converting fuel into thrust. The role of air. Temperature and pressure. In a jet engine, air is the primary working fluid, and its pressure and temperature are manipulated through compression and combustion to generate hot, high-pressure gases that are then expelled through a nozzle, creating thrust. Essentially, the engine takes in air at ambient conditions, compresses it to high pressure, heats it by burning fuel, and then expands the hot gas through a nozzle to produce thrust based on the principle of Newton's third law of motion. The efficiency of jet engine design. In a jet engine, air is the primary working fluid, and its pressure and temperature are manipulated through compression and combustion to generate hot, high-pressure gases that are then expelled through a nozzle, creating thrust. Essentially, the engine takes in air at ambient conditions, compresses it to high pressure, heats it by burning fuel, and then expands the hot gas through a nozzle to produce more efficiency. From ground to sky, the impact of jet engines. The future of jet engine technology. Hybrid electric systems. These systems can improve fuel efficiency and reduce emissions. Adaptive cycle engines. These engines can adjust their compression ratio to improve fuel efficiency at high altitudes. Variable bypass ratio turbofans. These engines can adjust the amount of air that bypasses the engine core to improve fuel efficiency and thrust. Ultrafan engines. These engines have a gearbox that allows the core of the engine to run at high speeds while the fan runs at a slower speed. Lightweight components. These components include compressors, combustion chambers, turbines, and